Welcome to the first lesson on time and work. In this video, we will be solving very easy questions on this topic. In other words, you can say that this tutorial includes questions which have easy level of difficulty. Now let us begin with our first slide. The formula for work is work done is equal to rate by which the work is done into time. Now, in order to find out rate or time, we're going to rewrite this equation by rearranging rate, work and time. So, rate will be equal to work over time and time will be equal to work over rate. Now, in order to find out combined rate, that is the rate of two or more things, we will have to apply some other formula for it. Right? So rate of work for A and B, or combined rate of A and B, would be equal to A plus B divided by A into B. Similarly, the time taken by A and B would be equal to A into B over A plus B. Now this can also be solved with the help of another formula, which is time taken by A and B is equal to T1, that is time 1 into time 2 over time 1 plus time 2, right? Now, if we have to find out the rate of three things, what we're going to do is we're going to take the LCM of A, B and C and divide it by A plus B plus C, right? Similarly, time taken by A, B and C would be equal to A plus B plus C divided by the LCM of A, B and C. Now you see, time is the reciprocal of rate of work done by A and B or A, B and C. Now the first question of this lesson says that Zan completes 1 unit of work in 5 hours. How much of the work would be completed by him in 2 hours? Now this 1 unit of work can be anything, like baking a cake, solving a question, etc. To solve this, we need to understand the relationship between time and work. Now time into rate at which the work is done gives us the amount of work done. Zan works for 5 hours and in that time frame, he completes 1 unit of work. To find the rate, we will transpose 5 hours to the other side. We get the rate as 1 unit of work every 5 hours. Now this is the rate at which Zan completes the work. The question asks us how much of his work will be completed in 2 hours. We have time into rate is equal to work done. So 2 hours into 1 over 4 will give us the work done in 2 hours. It gives us 2 over 5, which implies that Zan completes 2/5 of the work in 2 hours. And we can say that Zan completes 40% of his work in 2 hours. Right? This question on time and work says that Zen completes 1 unit of work in 5 hours. Zara completes 1 unit of work in 4 hours. How many hours will they take if they work together? Now let us use the most basic formula to solve this, which is time into rate is equal to work done. Let us take Zen's case first. He takes 5 hours to complete 1 unit of work. So his rate of work will be 1 unit of work every 5 hours. Zara takes 4 hours to complete 1 unit of work. Her rate of doing work will be 1 by 4. When people are working together, we should always add rates. Now the rate at which work will be done will increase. Things will get done faster, right? Now let us find the combined rate, which will be 1 over 5 plus 1 over 4, and solving this we will get 9 over 20 as our combined rate. Now we can apply this combined rate to the formula to find time taken by them together. we need to find the time taken. The combined rate is 9/20 and 1 unit of work is done. Solving this, we get the time taken by both of them together as 20/9 hours, which is a little over 2 hours. Individually, they take 5 and 4 hours, but if they work together, they do the same work in a little over 2 hours. Now, total time taken when they are working together can also be solved by the formula T1 into T2 divided by T1 plus T2, where T1 and T2 are the individual time durations. But please do not memorize without understanding the concept of time and work. If you have understood how to solve it, then you can use this formula. Another way of solving this could be to avoid fractions. So we can solve this by taking LCM of 5, which is 20. To understand this concept of LCM well, we will move to the next slide. This question says that A can do a work in 20 days. A and B together can complete the same work in 15 days. In how many days B alone can do that work? Now, in continuation with the last question, let us see how we can solve this problem. The best way to simplify this question is to take LCM of the number of days, that is of 20 and 15, which is equal to 60. So 60 is the total units of work that we have assumed, right? Now, if we write down the equation, that is time into rate of work is equal to work done, and write down the information that we have already been provided with in the question, we have A's rate of work and the combined rate of work, right? Now, we can see that A can do 3 units of work per day to do 60 units of total work. Similarly, if A and B work together, they can complete the same work in 15 days by doing 4 units of work per day. Now, you see, the trick is to add a number with 3, that is, to add the number with the rate of work of A to get a total of 4, which is the combined rate of work of A and B. Now you can see that 1 unit is the rate of work done by B to complete it in 60 days. Hence, our answer will be 60 days. You got it? The last question of this video tutorial is about combined rates, and it says that tab A takes 2 hours to fill a tank, tab B takes 3 hours to fill the same tank, and tab C takes 6 hours to fill that tank. How long would it take to fill the tank if A and B are open together, B and C are open together, A and C are open together, or A, B and C are open together? Now, the best way to approach this problem is to find individual rates. And we know that time into rate is equal to work done. Now, to find the amount of work done in different durations, we can assume the work to be equal to 1. But to avoid fractions, let us assume that the work done to be the LCM of the 3 time durations. Hence, the LCM of 2, 3, and 6 will be 6. Now, let us assume the work done in each case to be equal to 6, or that the capacity of the tank is 6 gallons. Now, let us look at the 3 cases of tab A, tab B, and tab C. The work done in all of the 3 cases is 6. Tab A takes 2 hours to fill the tank, and 2 times 3 will give us 6. That is the rate of A. It can fill 3 gallons every hour. Tab B takes 3 hours to fill the same tank, and 3 times 2 is 6. Tab B fills 2 gallons every 3 hours, which means it takes 3 hours to fill the entire tank. In case of C, 6 times 1 is 6. Tab C can fill 1 gallon every hour. Now you see, if we had assumed the work to be 1, our calculations would have involved fractions. So now if tanks A and B are open together, this means they are working together. So we add the rates. The time taken to fill the tank will be the work done divided by the rate. The work done is 6 and the combined rate is 3 plus 2, which is equal to 6 over 5 hours. Now if B and C are left open together, 6 will be divided by the combined rate of B and C, that is 2 plus 1, which is equal to 6. Hence, the time taken to fill the tank by B and C together will be 6 over 3 or 2 hours. Right? Now, same goes for A and C. Their combined rate is 3 plus 1, which is equal to 4, and the time taken by A and C to fill the tank would be 6 over 4 hours or 3 by 2 hours. Now, if A, B and C are open together, the combined rate of the 3 taps will be 3 plus 2 plus 1, which is equal to 6, which means it will take 1 hour to fill the tank if all the 3 taps are left open together. Now, whenever questions like these are asked, kindly assume a suitable value for work and then find the rates one by one. Once individual rates are calculated, the combined rates are very easy to calculate then. With this, we come to the end of our first video tutorial on time and work. I will be uploading more videos in the coming few days, so please stay tuned to this channel, stay positive, have a very nice day, and goodbye for now. Thank you.